Hello and welcome to day 8 of our Algebra 2 notes. The purpose of this video is to explain some of the notes that some of you guys may be missing due to a field trip, and also go through some new stuff in this that you might not understand fully if you just look at the notes. So hopefully this just provides some clarification on things if it's confusing looking at the notes on Google Classroom. If you hear some babbling in the background, that is Owen. So Owen says hello. Owen is 2.5 months old in this video. Alright, so looking at these examples on the first page of our notes, here's what's great about this lesson. The beginning of it just ties together everything that we've been doing. So, first example, we have a GCF taken out of x. I have a leading coefficient of 2 on my trinomial, so I did my triangle method. That factors to 2x minus 1, x plus 2, but don't forget that GCF of x. So when we end up teeing it up, I get 3 solutions, 0, 1/2, and -2. Coming on over to our second example though, I distributed the 2x squared, and then I put it into standard form. Now keep in mind, this is a degree 3 polynomial. Yes, it's a degree 3 polynomial. So therefore, I should end up with 3 total solutions. So I factored out a GCF of 2x. That left me with x squared plus x minus 3. Now from there, if I try to think of factors of -3 that sum to a +1, those don't exist. So what I end up doing is just the quadratic formula. Technically, you could do completing the square there, but I probably wouldn't because your middle term is odd and that just makes things weird. So yeah, quadratic formula, and you end up with 2 irrational solutions. -1 plus or minus radical 13 over 2, but then don't forget you had to set the GCF of 2x equal to 0 and solve, and so you get 0 as a solution as well. So 3 total solutions. I'm not going to go through all of these, but just some of the highlights. Something like number 3, notice how I didn't do quadratic formula with it. That brought us back to day 2 of our notes where we just did AM factoring. From there, you actually could have factored the x squared minus 4 further using dots, but I chose just to set it equal to 0 and solve. Same thing with x squared minus 1. Since it's a degree 4, we should have 4 total solutions, and that's what I ended up with, plus or minus 2 and plus or minus 1. So again, probably not going to fully explain all these, but you can go on Google Classroom. Please fill in your notes if you miss class, but hopefully that provides some understanding of what I'm doing here. Like this is another GCF and then a quadratic formula. I was going to say if I tried to do triangle on that, it wouldn't factor, and I know that because the radical 85 is not a perfect square. Okay, degree 5, I got a GCF, some AM factoring. This guy looks like triangle right off the bat. Notice how I do some rationalizing when I have the square root of 1/2. So I end up with plus or minus radical 2 over 2. And then lastly for 7, 4 terms. So that's typically a factor by grouping, and that's exactly what I did. Got plus or minus radical 2 and -1 as solutions. Again, degree 3 polynomial, so I end up with 3 total solutions. Okay, so like I said, hopefully this first page isn't too crazy difficult. It's just putting together everything we've been doing. It's the second page where things get a little bit more challenging. All right, so on the second page, we will use synthetic division to help us actually factor and solve other higher powered polynomials. So what if we know a factor or root to a function already? We can use that factor or root to help us break down a polynomial into a smaller one that's easier to factor and solve using our polynomial division. So for instance, I like to relate this back to when you guys were in middle school and you came up with prime factorization of certain numbers. So for instance, let's say we wanted to look at the number 30, and that's the example I have typed up here in our notes. Well, I know a factor of 30 is 3. 3 times 10 gives us 30. But I can break down 10 further into 5 and 2. So putting it all together, 2 times 5 times 3 would equal 30, and that's its prime factorization. So it's essentially the same thing, but just with polynomials. In our example 8, I'm telling you that I know that x minus 1 is a factor of f of x. So I can use that to help me do division to break down the polynomial. Okay, so I'm going to take this function, 1, 8, 5, negative 14, and I'm quickly going to do some synthetic division. Notice how my magic number, I like to call it, on the upper right is 1. That's because that's the root of x minus 1, the thing I'm dividing by. Notice how I get 0, as I should. That's a remainder of 0. I told you it's a factor, so if you don't get a remainder of 0, that means you're doing something wrong. So this is x squared plus 9x plus 14. So from there, that's x plus 7, x plus 2. Now what I want you to keep in mind here is that this function, f of x, is the product of these two factors and the factor you knew to begin with. So f of x is x plus 7 times x plus 2 times x minus 1. So these are equivalent. This is standard form, this is factored form. Now the problem is actually asking me for the zeros of the function, so the zeros would be negative 7, negative 2, and 1. When it said rewrite f of x as a product of linear factors, that's actually what I did right there. So two-part question, two-part answer. All right, so then let's look at number 9. Notice how there's a missing term of 0x. All right, so I've got 2, 0, negative 51, and 5. And it's known that x minus 5 is a factor. So that means I can use 5 in my synthetic division. All right, and I get 0, as I should. So this is 2x squared plus 10x minus 1. Now, if I try to do triangle method to factor this, that would be factors of negative 2 that sum to 10, and those just simply don't exist. So what you're going to want to do here is probably completing the square quadratic formula. Since not all these numbers are divisible by 2 with that leading coefficient there, I'm probably just going to do quadratic formula. I know, Owen. We're doing quadratic formula. All right, now this is usually where you guys mess up. Just use your calculator if you are not confident. In fact, I would say just always use your calculator to clean up the discriminant. 100, because that was b squared, minus 4ac is 108. I'm pretty sure 108 has a perfect square in it. I believe it's 36, and it is 36 and 3. So this is negative 10 plus or minus 6 radical 3 over 4, and then each of those reduced to negative 5 plus or minus 3 radical 3 all over 2. Okay, so those are two solutions. Now remember, we're finding the zeros. There should be 3 because this is a degree 3 polynomial. So here's 2. Don't forget your third one was x equals 5 because they told you x minus 5 is a factor. All right, question 10. I'm just putting this in a different way. I'm saying if f of negative 1 equals 0, what are the other roots? And then rewrite it as a product of linear factors. This is factor and remainder theorem. I'm going to put a star here. If I tell you f of negative 1 equals 0, the 0 is representing a remainder. And think backwards. If negative 1 is the root, x plus 1 would be the factor. So I can use that negative 1, which is the root of x plus 1, to do my synthetic division. All right, I get 0, as I should. So this is x squared minus 9x plus 20. Okay, factors of 20 that sum to -9 would be -5 and -4. So I'm getting roots of 5 and 4. So when it said find the other roots, these are my other roots. Remember, they told me x equals -1 basically is also a root. So those are my 3 roots, which makes sense to degree 3 polynomial. So then putting it all together, almost done, Owen. Putting it all together, my function would be the product of these factors. So x minus 5, x minus 4, and lastly, don't forget x plus 1 is also a factor. Okay, now to check out the last one, I think we got the idea here. Go to Google Classroom. Here they all are out. Okay, this one works out really nicely. I know! Almost done. If I tell you that 2 is a root, x minus 2 is a factor, do your synthetic division, break it down, and there's your roots. Alright, so this was a quick 11-minute video with some baby babbling in the background. Hopefully it helps.